Good morning students, my name is Suvas Vora, Assistant Professor of Electrical Department at Sri Swaminarayan Institute of Technology. So, analog and digital subjects, chapter number 1 is complete. चैप्टर नंबर 1 में हमने देखा था कि व्हाट इज़ द ओपन, व्हाट इज़ द एम्पलीफायर्स, हाउ द एम्पलीफायर्स इज used or applicable, then different classes of the amplifier, class A, B, C, EB, then others classes, then amplifier, then op-amp, then block diagram of the op-amp and equations of the op-amp. So what is the start with the new chapters, the linear applications of the op-amp. So first of all, what is the op-amp? So op-amp is the direct coupled very high gain amplifier with the high input resistance and the low output resistance. It also have the negative feedback is used. हम जो op-amp है वो very high gain या amplifiers है, उसका इनपुट रेजिस्टेंस और आउटपुट रेजिस्टेंस इज लो रहता है. इनपुट रेजिस्टेंस हाई होता है और आउटपुट रेजिस्टेंस लो होता है, और वो नेगेटिव फीडबैक भी हम यूज़ कर सकते हैं. सो बेसिकली हमने लास्ट चैप्टर में देखा था कि op-amp हैव द टू मेन पार्ट्स, और फर्स्ट वन इज द इन्वर्टिंग एंड अनदर वन इज द नॉन इन्वर्टिंग. सो नाउ स्टार्ट विथ द न्यू चैप्टर्स, द लीनियर एप्लीकेशंस. अब हमने देख लिया कि इन्वर्टिंग नॉन इन्वर्टिंग क्या है, देन op-amp देखा, बट जो देखा वो एक्चुअली आइडियल जो op-amp होता है उस बेसिस पे हमने पूरा जो चैप्टर नंबर 1 में देखा वो था. नाउ द टुडे स्टार्ट विथ द टॉपिक ऑफ द टुडेज टॉपिक इज द इन्वर्टिंग नॉन इन्वर्टिंग कॉन्फ़िगरेशंस एंड द डिफरेंशियल एम्पलीफायर्स. सो जैसे मैंने बताया कि आइडियल op-amp और प्रैक्टिकल op-amp में क्या डिफरेंस होता है, तो यू कैन सी हियर. सो फर्स्ट ऑफ ऑल द फर्स्ट वन इज द करेक्ट ओपन लूप गेन. ओपन लूप गेन जो गेन होता है वो तो आइडियल में इनफाइनाइट होता है, बट व्हेन वी यूज इन द प्रैक्टिकल फील्ड दे हैव द लेस देन और ग्रेटर देन 10⁴. ये पूरा जो हम देख रहे हैं वो एक्चुअली जब हम कैलकुलेशंस करते हैं तब यूटिलाइज होता है, जब op-amp मैन्युफैक्चरिंग होता है. तो देन आफ्टर द ओपन लूप बैंडविड्थ, तो आइडियल कंडीशंस में इनफाइनाइट होता है, बट इन द प्रैक्टिकल अप्रॉक्सीमेटली 1 मेगाहर्ट्ज. देन इनपुट इम्पीडेंस इन आइडियल इज 0, बट द प्रैक्टिकल इज ग्रेटर देन और इक्वल टू 10⁵ ohms. देन आउटपुट इम्पीडेंस Z0, ideal is 0, but in the practically when we use the consider the output impedance at that time is the values is less than the 500 ohms. Then CMRR, common mode rejection ratios, ideally is infinite, but in the practically greater than or equal to 700 dB. dB means the bandwidth, यानी कि उसका जो यूनिट्स है वो है. इनपुट ऑफसेट वोल्टेज इज 0, बट इन प्रैक्टिकल फील्ड द वैल्यूज इज लेस देन द 10 millivolt. इन द इनपुट ऑफसेट करंट इज आइडियली 0, बट द वैल्यूज इज प्रैक्टिकल फील्ड इज लेस देन 20 nanoamperes. सो बेसिकली यू कैन सी हियर द आइडियल op-amp diagram and the practical op-amp diagram. Ideal conditions में they have to know impedance between the inputs, so the values is different from the ideal conditions. में क्या होता है कि input resistance जो हम यहाँ पे देख सकते हैं चेंज Zin, input impedance कंसिडर नहीं होता है. यहाँ पे हमने देखा input impedance is infinite, यानी कि पता नहीं है, बट आइडियल कंडीशंस में फिक्स वैल्यूज होती है. सो दीज आर द बेसिक डिफरेंस. फिर आइडियल कंडीशंस में आउटपुट 0 होता है, बट यू कैन सी हियर द आउटपुट ऑफ द प्रैक्टिकल विल डिफर. सो दीज आर द basic difference between the ideal and practical op-amp. Now the important characteristics of the op-amps. So the first one is the ideal op-amp conditions की बात करते हैं हम. So you can see the figures. Yes. So the important characteristics of the ideal op-amp as differ from the two. You can see here there are the two difference. We can bifurcate. So you can see here there are the two main different part, input part and the output part. So the input current into the both the input terminal are zero. If मैं कंसिडर करता हूँ कि इनपुट करंट जो इनिशियल लेवल है I0 आइडियल कंडीशन है, तो इनपुट करंट इज जीरो, I1 एंड I2 इज जीरो. So the I1 equal to 0 and I2 is equal to 0. This is due to the infinite input resistance, and the infinite resistance between the input terminal implies that the open circuit exists. There are the current cannot enter the op-amps, यानी कि current is not enter the op-amps. Now the second part is the difference voltage across the input terminal is negligibly small, यानी कि अगर जो वोल्टेज है वो डिफरेंस है, यू कैन सी हियर द V1, यहाँ पे हमने एज्यूम किया है कि V1 और यहाँ पे एज्यूम किया है कि V2 इज अप्रॉक्सीमेटली वैल्यूज इज V1. सो उसका डिफरेंस यानी कि VD मीन्स द डिफरेंशियल वोल्टेज V2 माइनस V1 इक्वल टू 0 बिकॉज ऑफ V1 इक्वल टू V2. So therefore the ideal op-amp has the zero current into its the two input terminals and the negligibly small voltage between the two input terminals. Now the next one is the ideal voltage transformer curve. So ideal voltage transformer curve, the voltage transformer curves may be defined as a curve which is drawn between the input and output voltage, and the op-amp, the input voltage is VD and the output voltage is V0. So these are the input output voltage diagram of the slope. In a practical limitation of the op-amp is the magnitude of its the output voltage cannot be exceed, you can see here they cannot be exceed the VCC, you can see here. In other words, the output voltage is depends and the limits by the power supply voltage. So first one is the magnitude of the its output voltage cannot be exceed of the VCC, and another one, the op-amp can operate in the three modes depending on the differential voltage. The first stage is the positive saturation, V0 is equal to VCC. Here V0 is equal to, यानी कि V0 means the output voltage is VCC. Then linear regions, so the regions is VEE to VCC, यानी कि this dotted line to this dotted line. And the negative saturations, यानी कि नेगेटिव में अगर मैं ड्रॉ करता हूँ तो मैक्सिमम वैल्यूज इज द आउटपुट वोल्टेज इज माइनस VEE. सो these are the we can attempt to the increase the differential voltage beyond the linear range, and the op-amp become the saturate and the output voltage is V0 equal to minus VEE, and the in the positive values is V0 is equal to VCC. So these are the ideal voltage transformations curve. Then the open loop and closed loop gain. So the maximum possible gain provided by the given op-amp is referred to the open loop voltage and is denoted by the AOL, यानी कि open loop gain, and the value of the open loop gain is generally greater than the 10,000. नाउ फॉर एग्जांपल्स में बात करता हूँ कि जो ओपन लूप गेन है वो PE741 op-amp is open loop gain is the 2 lakhs values. Now the term open loop indicate the circuit conditions where there is a no feedback path from the output voltage to the input voltage. So the circuit connecting of the RF यानी कि feedback resistor path when the part of the output signal is feedback to the input and the effective gain of the op-amp is reduced. The gain in the feedback circuit is called the closed loop gains. So you can see here the open loop and closed loop circuit. Open loop में there are the no feedback path and closed loop path is considered as a feedback path. So these are the basic difference between the open loop and closed loop gain. Now start with the inverting configuration. So inverting configuration is the basic circuits, and in this circuits you can see that the non-inverting terminal is grounded. यहाँ पे आप देख सकते हो कि नॉन इन्वर्टिंग टर्मिनल है वो ग्राउंड किया गया है एंड द इनपुट वोल्टेज V1 is applied to the inverting terminal through the resistance RE. So the feedback resistance RF. So the feedback resistance RE is connected between the inverting input and the output terminal, and this arrangement from the negative feedback because the output is 180 degree out of the phase within the input. So from the figure we can apply the KCL at the node I1. So here if I applying the KCL at the node, so value it means I1 is the entering current is the feedback current. So here the input current I1 is input voltage minus output voltage upon you can see that the RA यानी कि R1. So the output current IF feedback current is the VA means we can consider the V input minus V output upon R2 यानी कि feedback resistance. So therefore if I equate the two values, तो हम ये दोनों वैल्यूज I1 इक्वल टू IF कंपेयर करते हैं. सो बट V1 must be equal to V2 for the inverting amplifier and the non-inverting terminal is grounded. So you can see here the V2 value is 0, V1 equal to V2 equal to also 0. So therefore the voltage in the inverting terminals is given by, so value is V1 equal to VA equal to 0 यानी कि V input is 0, so that the VI by R1 equal to minus V0 by R2. So the output voltage V0 is minus R2 by R1 into input यानी कि output voltage is dependent on the ratio of resistance into input voltage. So the closed loop voltage gain is given by, you can see here the gain is V0 by V1 VI यानी कि output voltage by input voltage is equal to the ratio of R2 by R1. So these are the closed loop voltage. So concept of the, अब हमने जो सर्किट देखी उसके बेसिस पे हम कॉन्सेप्ट ऑफ द वर्चुअल ग्राउंड की बात करते हैं. तो द पॉइंट इन द एनी सर्किट इज सेड टू बी ग्राउंडेड इफ द पोटेंशियल्स एट द पॉइंट इज इक्वल टू ग्राउंड प्रोटेक्शंस. इफ द पॉइंट इज कनेक्टेड टू द ग्राउंड विद द हेल्प ऑफ द एनी कंडक्टिंग वायर्स, then all the currents from that point will be flow towards the ground, and point is said to be the physically or mathematically will be ground. यानी कि जो वर्चुअल ग्राउंड है जहाँ पे वैल्यूज़ बाइफरकेट हो गए, वहाँ वैल्यूज़ को हम जहाँ पे पोटेंशियल्स डिफरेंस है जो इक्वल टू ज़ीरो होगा, उस पॉइंट को हम बोलते हैं वर्चुअल ग्राउंड. सो वी कैन in the case of the virtual ground only the conditions for the potential is satisfied. So the open gain values A is equal to V0 by Vd. Vd means the differential voltage, and the differential voltage we know that the V2 minus V1. So therefore the values of the gain is equal to V0 output voltage upon the V2 minus V1. So we can say that the output voltage, the differential voltage V2 minus V1 is equal to V0 output voltage by gain. Now if I consider that the ideal op amp, जैसे हमने आके स्टार्टिंग में देखा था कि आइडियल op amp में गेन इज इन्फिनिटी, so the value is 0. So V2 minus V1 equal to 0. So at that point we can say that V1 equal to V2, यानी कि V1 is equal to 0 due to the virtual ground. So इस इक्वेशंस का हमको ये पता चलता है कि यहाँ पे वोल्टेज दोनों सेम है, यानी कि ज़ीरोज़ है. डिफरेंस में जब करता हूँ तो वैल्यू ज़ीरोज़ है. So in this virtual ground point the voltage V1 is equal to V2. Now the concept of the virtual ground, the effect of the finite open loop. So you can show the figures, you can see the figures here. The inverting configurations taking into the account the finite open loop है, finite open loop है, and the closed loop gain is the dependent on the external resistance R1 and R2 when the open loop gain of the op amp is assumed to be infinite. So यहाँ पे हम open loop कंसिडर करते हैं, तो क्लोज लूप कंसिडर करते हैं. तो करंट I1 थ्रू दी R1 कैन बी रिटन एज I1 इज इक्वल टू V1 माइनस आउटपुट वोल्टेज बाई गेन अपॉन R1, सो दैट दी I1 इज इक्वल टू V1 प्लस V0 अपॉन A अपॉन R1. एक इन्वर्टिंग के लिए है, दूसरा नॉन इन्वर्टिंग के लिए. सो द करंट I1 will not be flow into the op amp because of the finite input impedance. Therefore, the current I1 flow entirely through the R2. So the output voltage V0 can be defined as V0 is equal to minus V0 upon A minus I1 R2. So substitute these values in the equation. So output voltage V0 is equal to V0 upon A minus V1 plus V0 by A. You can see here this value, put the values in R2. Then after bifurcate V0 एक साइड कर देंगे. So the V0 plus V0 upon A is equal to minus V1 R1 minus V0 R2 upon A2. अगेन ए V0 को इस साइड ले जाएंगे. देन आफ्टर द फाइनल इक्वेशंस द V0 इंटू 1 प्लस 1 अपॉन ए इंटू 1 प्लस R2 अपॉन R1 इज इक्वल टू माइनस V1 R2 अपॉन R1. नाउ वी कैन कंसिडर द क्लोज लूप गेन. फाइंड द वैल्यूज ऑफ गेन इज इक्वल टू V0 अपॉन V1. So final equations V0 upon V1 equal to minus R2 by R1 upon 1 plus 1 upon A into 1 plus R2 by R1. So these are the effect of the finite open loop gain values. Now start with the non-inverting configurations. So non-inverting amplifier is the open circuit designed to provide the positive voltage gain, and this input is applied directly to the non-inverting voltage gain, non-inverting values or terminals. So the non-inverting amplifier is an open circuit designed to provide the voltage gain. You can see the figures. In this case, the voltage Vin is applied, is connected between the ground and the inverting terminals. So input is applied in the non-inverting terminals. Now the expressions for output voltage and the closed loop gain. So differential voltage Vd at the input terminal of the op-amp is 0, so that now R2 and R1 in the circuit is potentials divider circuit. So you can see here potential divider circuit. So you can see here the voltage at a node A is VA equal to, VA means the input voltage is equal to output voltage into R1 upon R1 plus R2. Node voltage A is same as the input voltage, so the VA equal to Vin. So Vin equal to V0 into R1 upon R1 plus R2. Now the output voltage values is V0 equal to R1 plus R2 upon R1 into Vin. So the output voltage V0 is equal to 1 plus R2 by R1 into Vin, and the closed loop gain values G is equal to V0 upon Vin equal to 1 plus R2 by R1. So these are the values of the non-inverting values for the closed loop. Now the effect of the finite open loop circuits. You can see here the diagram. Here the non-amplifier with the finite open loops, and the open loop input resistance is assumed to be infinite. So we have I1 equal to I2. So I1 values is minus V1 upon R1 equal to V1 minus V0 upon R2. ये जो वैल्यूज़ है V1 अपॉन R1, ये यहाँ तक का वैल्यूज़ है इनपुट पार्ट. आउटपुट पार्ट में यहाँ पे आएगा V1 माइनस V2, यानी कि V1 माइनस V0 आउटपुट वोल्टेज अपॉन R2. So you can simplify these equations. We get the V0 upon R2 equal to V1 into 1 upon R2 plus 1 upon R1. So V0 is equal to AVD, यानी कि डिफरेंशियल वोल्टेज गेन्स. सो V0 इक्वल टू A V2 minus V1. So we know that V2 equal to V1. So V0 upon A equal to V2 minus V1. So V1 values is equal to V1 minus V0 upon A. So substitute these values in the equations. V0 equal to V1 1 plus R2 by R1, जैसे हमने आगे फाइंड किया. सो V1 माइनस V0 अपॉन A इंटू 1 plus R2 by R1. Simplify these equations, we get the final equations V1 into 1 plus R2 by R1. So the closed loop gain values is G equal to V0 V1 equal to 1 plus R2 by R1 upon 1 plus 1 by A 1 plus R2 by R1. So the final gain values is 1 plus R2 by R1. So these are the values of the infinite open loop gain. Is similar for the non-inverting values. Now differential amplifiers. Now what is the differential amplifier circuits or amplifiers? A differential amplifier is one which is responsible to the difference between the two signals applied at the input and ideally reject those signals that are common to the two inputs. So representations of the signals in the terms of their differential and the common mode rejections values. You can see the figures now. So if these are the differential amplifier circuits, the values of the sources is, you can see that common mode input voltage, then VID differential voltage by 2 and the final equation for the here is VICM plus VI by 2 in same of the outputs. So the differentials amplifier is one which responds to the difference between the two signals applied at the inputs. अब ये दो signals जो है हमने देखा अभी वो applied करते हैं at the input and ideally reject those signals that are common to the two inputs. Now the output voltage V0 is given by V0 equal to differentials gains into input differential voltage plus common mode gain into common mode input voltage. So AD, you can see here is the amplifier differentials gains and ACM common mode gains. So the final equations or the common mode rejections is 20 log mode of AD upon mode of ACM. So these are the equations for the differentials amplifiers. So if any query regarding this today's topic, you can call me. If any questions regarding this topic, you can maybe. My mail ID and the contact number is in your screen. Thank you.